Good morning, everyone. Today's lesson is going to be over the triangle congruence theorems that we are going to be using so that we can do our proofs to prove that triangles are congruent. Today, you just finished taking your quiz for the CPC-TC theorem, and hopefully you mastered that standard. Go ahead and check your mastery tab in Schoology to see what it is. If you think your mastery is not at the level you want it, please make sure that you sign up for map time next week so that we can get you into tutoring and so that we can reassess and go over the CPC-TC. But today we are moving forward with triangle congruence theorems. They're kind of like shortcuts so that we don't have to do all the angles and all the sides of a triangle and make sure that they're all congruent so that we can say that they're congruent. So these are kind of like shortcuts, and they're very specific and they're very, very detailed about what you need. And so in a triangle, remember, we have angles and we have sides. And using those, we are going to talk about these 5 theorems and see what they need in order to use them. So the first one is the side congruence theorem. And so this one says that if 3 sides of one triangle are congruent to 3 sides of another triangle, then those 2 triangles are congruent. They do have to be corresponding sides, obviously. We have to establish that first. So if we look at the example we have this triangle, and it says that, it doesn't say it. You can see that all 3 sides that are corresponding are congruent. And so we can use that theorem to prove that those 2 triangles are congruent. So these 2 triangles, I'm going to go ahead and label it and say triangle MNL is congruent to, who corresponds with angle M? For the other triangle, can you see it? Angle S. And then who corresponds with angle N? Angle T. And who corresponds with angle L? Angle R. Okay? But I am going to say that I know that these are congruent because of the side theorem. Okay? The next one is SAS, which is side angle side. And it says that 2 sides and the included angle. Another way you can think of included, think of like in between. So this included angle in between the 2 sides. And 2 sides and an included angle of another triangle. If you have that and they're corresponding and they're equal, congruent, then those 2 triangles are equal. So if you look at our picture, you can see that the angle is in between the sides. It has to be in between. Included. So here's one side, here's the angle, here's the other side. Here's one side, here's the angle, here's the other side. And they are marked with our congruence markings, saying that they are congruent. So now we can say that those 2 triangles are indeed congruent. By which theorem? The side angle side theorem. So let's name these triangles and write our congruence statement. I'm going to start with the first triangle. And remember, the order does matter, but you can pick, as long as you start the first one, whichever way you want to start it, make sure that the second triangle matches the sides and the angles of the one that you started with, okay? What order do you all want to do? Oh, wait, this is a video. I'll choose myself. Okay. I'm going to do L, N, M. Okay, so you think about that. Who is congruent to L? We kind of already is the same letters as the triangle above. So you should be able to see it very easily that triangle LNM is congruent to triangle RTS. Okay. And how do you know? Because I used the side angle side theorem. Okay. And please make sure that you're looking at the picture. Pictures are our best friend. They show us everything. Okay. Angle side angle. That is the next theorem that we're going to look at. And this one has 2 angles. And in between those 2 angles, you have an included side. Included side. okay? Don't forget that when we're doing these videos, you can pause it so you can write everything and then you can press play again, all right? Don't break your hand. Two angles in the included side of a triangle are congruent to two angles in the included side of another triangle. And we have our beautiful image here. So this one is different. This one has two angles, and in between those two angles, you have the included side, and they have to be the same. They have to be congruent in order for you to use this theorem. So in our picture, we do have that. We see that our arcs and our sides are marked, and you can see the angles, and then you can see the side that is included in between them, okay? So let's write our congruence statement. I'm going to start with this side. Triangle X, Y, Z, let's just go in order, is congruent to triangle, who corresponds with X. Sorry, let me make that S. And then who corresponds with Y? Angle T. Oops, I said Y and I wrote it. Angle T. And then angle Z corresponds with angle R. So those two triangles are congruent, and we proved it because we have the image, and we can automatically say that they're congruent with the angle side angle theorem. The next one, angle side. This one says that two angles, two angles, blanked out, and the non-included side, it is not included in between them, of a triangle and is congruent to two angles and the non-included side of another triangle. So this one is very, very different from the one we just did up here, okay? Notice how the S is not in between the angles. That means that this side is not included in between. It's going to be on another side of the triangle. So here's our picture to represent that, and you can kind of see how it does not show you an angle and a side and an angle. It shows you an angle, and a side. Okay? And so let's name the triangle. I'm going to go in order again. PQR is congruent to triangle triangle EFG. Okay. One of the very cool tricks that a lot of students use is label what you have. This is an angle. This is an angle. This is a side. This is an angle. This is an angle. This is a side. That kind of gives you the answer, right? It tells you that for this triangle, we're going to be using which theorem? The angle side theorem. Okay. And you can actually do that with all the ones beforehand. I just didn't do it. We'll go back and do that at the end. Okay, let's finish this. The last one is the hypotenuse leg theorem. That's what the H stands for. This one is so important because you can only use it with right triangles only. No other triangles, only right triangles, okay? It says that the hypotenuse, who remembers that word, hypotenuse? You should have heard it before whenever you learned how to do Pythagorean theorem for right triangles. We use the hypotenuse and one leg of the right triangle to prove that it is congruent to another triangle that has the corresponding right angle and a congruent hypotenuse and a congruent leg. So who is the hypotenuse here in this triangle ABC? This is the hypotenuse. This is the leg, one of the legs. You could have used the other leg, but for this one, we used that one. Here's the other hypotenuse on the second triangle, and then the leg here. So to write our congruence statement, we are going to say that triangle ABC is congruent to who matches with angle A, who corresponds with angle A. Do you see it? Angle L, and then we go in order, M and N. All right, I'm going to go back and label these so that you can do that as well. This one was angle, side, angle, angle, side, angle, side, angle, side, side, angle, side. And this one was side, side, side. Side, side, side. Okay. All right, and then we're going to go over the helpful hints that we can use when we are using these theorems, because you're always going to have different triangles, different images, different problems, and we just want to make sure that you know that these are the hints that will probably help you a lot. Okay, so the first one is the reflexive property, which says that if two triangles share a side, they have to share a side, or an angle, then we can always mark it congruent. And how do we mark a side that is congruent? Well, they already marked two of the sides here. Let's mark the side that they share. What side do they share? What side length? Because these two triangles are stuck together. Which side are they sharing? Right here. What side is that? You can either name it segment RT or TR, but that is the side that they're sharing. So I can mark it with my pencil and say that that side is congruent for both of them because it's the same side. It is what it is. It is the side, and it is the same side. So they're sharing it, so it is congruent. And that is what the reflexive property says, okay? It's the same for angles. The vertical angle theorem. This is something we should live and breathe and know in our sleep. Vertical angle, if you have a vertical angle, you should be able to identify it in the diagram. So once you identify it, go ahead and mark it because some of them won't mark it for you. So you should have to do that so that it can help you find what theorem we're going to use. So for this one, the vertical angles are right here. So we use our arcs and we know that those angles are congruent. They're opposite. They're in front of each other. They're across from each other. Whatever helps you, just mark it because those are vertical angles, okay? And that is it. So let's go over some examples so that you can do your practice, okay? These are not in your notes. Just look at them with me, okay? I have this triangle. There's no letters. There's nothing. I just want to know, are they congruent? What do you think? I know that the sides are congruent. So I have one letter. I can say that these are vertical angles. So I have an angle. Do I have anything else that can be used so that I can use one of the theorems? Not really. So this one has not enough info. Not enough information. Oops. Okay. What would we need to prove this correct, though? What do you think? We could have had something given to us that would have allowed us to use one of the theorems because we have a side and an angle, right? So we could have used side angle side if they would have given us another side. We could have used angle side angle, or we could have used angle angle side, but they didn't give us enough information, so we can't. Let's look at this one. These two triangles, I'm gonna label the vertical angles just because I see it right there, okay? And I can see that I have a side, an angle, and an angle. Okay, so what theorem will we be using for this one? Angle, angle, side. Angle, angle, side. That is one of the theorems. Okay, I'm not going to write the congruent statement. We're just going to identify which one would you use. All right, this one. Well, there I can see that they share a side, right? So this side is congruent. So I have a side, and a side. So I will be using the side, side, side theorem. Okay. This one, okay, let's see. I have an angle, and an angle, and they're congruent for both of these triangles, but are they congruent? Is it enough information? I don't think so. Visually, obviously, we can't assume things, but just having the same angles doesn't prove that they're congruent because those side lengths are not the same. So this one, We do not have enough info. And angle is not one of our theorems. So don't make up theorems, please. We cannot use that one. What about this one? These two triangles share a side right here, so that one is congruent. They both have the same side. So let's label it. We have an angle, we have a side, and we have an angle. Can we use angle, side, angle? The answer is yes, we can. Angle, side, angle. We can use that one. And that is it. All right. So right now, when you're done, please glue your notes and then go ahead and go to Schoology so that you can do the practice. So you're going to go to this folder, go to Triangle Congruence, and then you're going to go to Proving Triangles right here where it says November 2nd to November 10th. And then you're going to go to Practice It. It's going to be this one, November 4th. And it is going to be a quizzes. Okay, so press it, and it'll take you to it. All right.